Hello everyone, welcome to this video. I hope you're all doing well. For some emergency, I had to come home and I'm recording from my laptop. I hope that is fine. The next few videos are going to be like this. But yeah, we'll continue with whatever we were solving. Last video on this problem solving series, I did CMI number theory problems. And today we'll cover CMI geometry problems. Although I covered only 2 or 3 questions, we will cover more questions. It will be interesting. Uh, but yeah, here we go. Uh, I don't know what else to say in the introduction. So I hope it's fine. I hope this size of mine is fine on the screen. So let's just begin. Okay. So what do we have here? First question. Just have a look at it. Please pause the video. Try it for yourself for once. This has to do with have you ever wondered, guys? Have you ever wondered why we have SSS congruency, SAS congruency, ASA congruency, and there is RHS congruency, but there is no SSA congruency, right? I mean, we never take two sides together and an angle, two sides together and an angle, right? This side is given, this side is given, and this angle is given. We don't get it. Why? This question is related to that. And the only case where this works is this. RHS is actually a case of SSA, where the angle specifically is right angle, right? So if you look at this question, this is specifically that. I hope you have paused and tried it for yourself once. ABC is a triangle such that AB is 1. So let's try to draw that. AB is 1. CAB is 20 point something degrees. So I suppose that would be something like this. 20.21 degrees. So I suppose this was a question on 2021 paper. Let n of x denote the number of congruent triangles such that BC is equal to x centimeters, where x is positive real number. Now we are given that this is 1 and this is C and BC happens to be x. So how many triangles are possible? So you have to note that this is SSA, right? SSA or ASS, whatever you want to spell it out like. So something we will observe something which probably you never wondered why. Yeah. Now we are just given this angle. This length could be anything. C could be anywhere on this ray. It is a ray, right? Let's say the perpendicular distance from B to this is P for perpendicular distance. That's it. So perpendicular distance from B to AC bar, right, is P. That is possible. Now we see that if x is equal to P, then we have only one triangle, unique triangle. If this was C, ABC would be a unique triangle with the given description. It depends on what is the value of x, right? Implies unique triangle. And this is the unique triangle which we get in the RHS condition. Right angle, hypotenuse, and a side. This is the condition. This is the RHS condition, right? But suppose we have this AB here and we have this 20.21 degrees here, and suppose my x is greater than P. What happens? If x is greater than P, you see, if you take a, what is that called? It's called a compass, I think. It looks something like this. Yeah, it will carry your pencil here or pen here, and then it will have a long needle kind of a thing. And with this, if you are trying to you put the needle here and you cut, you measure x on this, and if you cut it here, you'll see that simultaneously you will be able to cut it twice. So with length x, you will have two different this thing, two different triangles. So with the given measurements, you can have some C1 here and C2 here. You can have two triangles. Both ABC1 and ABC2 both satisfy the given condition. Given condition. I'm just noticing that my handwriting is much better when I'm doing it on my laptop. Okay. So in that case, you'll have two triangles. Two triangles. Right? So if it was equal to x equal to, we had a unique triangle. So if you see what is n of x denotes the number of non-congruent triangles, right? So we have exactly one unique, like one congruent, one triangle, basically one shape, which can be, shifted here and there, but n of x happens to be one. If n of x is one here, here n of x is 2. But if you see that, obviously, if I have AB here, this is 1 centimeter, and I have the same angle here, 20.21 degrees, and the length is shorter, I will not even reach. If x is less than the perpendicular, I will not even reach. So there is no triangles formed, no triangles. So n of x is 0. I hope you observe this. So this is the that's why I find this very interesting, because it deals with the fundamental understanding of construction of a triangle, right? Many people would ignore this, even preparing for IOQM or something. The construction of triangle is so important. I have talked about it whenever I used to mention, like in the geometry playlist. If you go there, you'll see that I have indeed talked about the construction of triangles when talking about congruency. So I hope you found that helpful from this. So yeah, so n of x equal to 1 happened, n of x equal to 2 happened, n of x equal to 0 happened. So all of these are possible except for this. This is the only thing which is not possible. There exists an x such that, yeah. So there will not exist any x such that you will have three triangles, three non-congruent triangles, all right? So I hope that's clear from this question. If it were a live session, I would have asked any doubts or something. Okay, so again, pause the video and please try this question for yourself. I hope you have paused it. So I'm directly jumping into drawing a diagram. Okay, so let's say ABC. In triangle ABC, BE is a median. So E is midpoint of AC, BE is median. M is the midpoint of BE. M is the midpoint of BE. The line passing through the points A and M meets BC at D. So if I join AM and extend it, it meets here at D. What is the ratio of AM is to MD? This is the question. Again, if you want to pause the video, you can pause and try. Right? So there is one little construction which will make the solution very easy, right? So the construction or hint I would like to give you is that draw. So this is hint. Draw EF parallel to AD. Yeah, try to do that. So if I draw EF, it doesn't look parallel. Just a minute. EF parallel to AD. This is F. These two are parallel. So what happens now? You see that this is midpoint and these two are midpoints as well. Yeah. So if you look at triangle BEF, BEF, then you see that MD is the MD is parallel to EF and M is midpoint of BE. So by the converse of midpoint theorem, I hope you remember that converse of midpoint theorem, we will know that D is midpoint of BF, right? So you can actually find the same thing drawn here much better. So these two were equal. These two are equal. So we find that if we find that BD is equal to DF. So if this is X, this is also X. Now, we can find something similar happening in the lower triangle. If you look at the lower triangle, what is the lower triangle? In triangle ADC, yeah. Again, E is the midpoint of AC and EF is parallel to AD. Now that would imply that F is midpoint of DC. That would again mean DF is equal to FC. That means this is X. So we found that D and F trisect the side BC. Yeah. So how is that going to help us? Uh, midpoint theorem tells us something else also. It tells us that EF is equal to half of AD. Right? EF is equal to half of AD. And it also tells us from the above thing that MD is equal to half of EF. So what do we have here? We have MD is equal to 1/4 of EF. If MD is that, AD is equal to twice of EF. AD is what? AD is AM plus MD and EF is 4MD. 4MD and we have twice. So I'll write EF is equal to 4MD. So I'm writing it as 2 times 4MD. So I have AM is equal to 8MD minus MD, which is 7MD. So AM by MD is 7 by 1. So that would be the answer. This is 7:1 ratio. Yeah, that's what we need, right? AM is to MD. It is 7:1. So that's the solution of this question. I hope you were able to figure it out. And I really mean that you want to pause the video and try it for yourself. Otherwise, it won't be as fun. All right. So let's go to the next one. In this triangle PQR, the bisector of angle P meets the side QR at D. The bisector of, so I again pause the video, try it for yourself. Bisector of angle Q, so this is also bisector. So let's say this is alpha, okay, meets the side PR at E, given that DE is parallel to PQ. Interesting. Show that PE is equal to QD and the triangle PQR is isosceles. If this is shown, this is obvious, right? Because if this is parallel, DE is parallel implies immediately, what does this imply? RE by EP is equal to RD by DQ, right? So if EP is equal to DQ, that means RE is equal to RD. So basically, this will directly imply that RP is equal to RQ, right? So it is enough to show that P is equal to QD. Now you see that if these two are parallel, alternate interior angles. If this is alpha, then this has to be alpha. And if this is theta, this has to be theta. So do you see that triangle DEQ? This has to be isosceles. right? This is alpha, this is alpha. So if you see in triangle this, DE has to be equal to DQ. And in triangle EPQ, EPD, sorry, EPD. Again, this is theta, so you have to say that ED is equal to EP. So ED is DQ also, ED is EP also. So EP is equal to DQ. So if this is happening, then we saw that by basic proportionality theorem, RP has to be equal to RQ. Huh? These are all B paper questions, UGB, the lengthier paper questions. So at least the first few questions, which happen to be a bit easier compared to the rest of them. But still, come on, so easy, right? They try to intimidate you, but you don't get intimidated. So that's how it works. Last question for today. Um, okay, so ABCD is a square. Point X lies on a circle with AY as diameter. So if AY was a diameter and X is lying on a circle, what is the property? If this was something like this, so what would you say about this? Immediately you should be saying that this is 90 degrees. So this is a 90-degree triangle, right angle triangle. Points X and Y lie on the sides. AX is equal to 4. AY is equal to 5. What is the area of the square? Okay. Again, pause the video, try it for yourself. I hope you had done that before itself, before my saying it. Let's say the side length of AD is A. The square side is A. Acha, immediately can you say something? We definitely can see that AXY is 4, 5. So by Pythagoras theorem, you can figure out that this is 3. Yeah. And if this is A, and this is 4, do you see the similarity? So suppose this is alpha, this angle is alpha, this is 90, this is beta. This beta 90, so this has to be alpha again and this has to be beta again because this is 90. Angle chasing, a little bit of angle chasing, not too much of it. So you will see that triangle ADX is similar to triangle XCY, right? So that would mean that AD by, okay, let's say this is B. Yeah, AD by XC is equal to DX by CY is equal to AX by XY. And AX by XY we know that is 4 by 3. So we know each of these actually. So we know XC is equal to XC would be equal to so a 3/4 of A, right? Because AD was A, so A by XC. So basically A by XC was equal to 3 by 4. So yeah, this is what you get. And similarly, DX was B. So B by CY was 3 by 4. So CY is equal to, this was 4 by 3. 4 by 3. Yeah, 3/4 of B. So this is 3/4 of A. This is 3/4 of B. Okay. What can you say about B exactly? One thing I can definitely say is A square plus B square is 4 square because that is a right angle triangle. This is a right angle triangle. And what else can I say? I can say that this side length, we know CD. CD is equal to AD. This has to be true. That means b plus 3/4 of a has to be equal to a. So b is simply 1/4 of a. So we have that. So from here we'll get a square plus a square by 4 square is equal to 4 square. So basically uh, a square into 17 by 16 is equal to 16. A square is equal to, which is area, is equal to 256 by 70. So yeah, a very simple question. Similar triangles and all that can be used and solved. So I hope you enjoyed this video. I hope this format is okay for the next few days. And I hope you're all doing well. That's it. Take care. Bye bye. Hello everyone, welcome to this video. I hope you're all doing well. This is the continuation of this problem solving series from CMI PYQs. And today we'll touch upon algebra and specifically the part of polynomials. Now, polynomials is a very interesting topic, especially because it is in the intersection of algebra, coordinate geometry, and calculus. Right, so coordinate geometry because you can talk about the graph of it and everything. Calculus because increasing or decreasing or how many roots is related to the derivative properties. And yeah, it's a very interesting thing. So without further ado, let's start. Just resize myself down here. I hope that's fine. All right. So maybe go a little bit bigger. All right. Here we go. So let's go. First question. Pause the video. Give it a try. Okay, the question says this complex number I minus 3, right? I minus 3 is a root of this polynomial and the polynomial has real coefficients. Now, since the polynomial has real coefficients and one of the root is complex, that means the conjugate of this complex has to be another root of this polynomial, right? So so always remember, I hope you should be knowing this, if a plus ib is a root, implies a minus ib is also a root. When does this happen? Whenever coefficients are real. All right. If the coefficients are real, then if this is a root, then this is also a root. So in our case, since I minus 3 is a root, implies minus I minus 3 is also a root. Right? So we can write P of x as x minus I plus 3 into x plus I plus 3 into some ax square plus bx plus c, right? Because it is a degree 4 equation, degree 4 polynomial. So that is there. So if I multiply this, what am I going to get? So x square and then the sum of the roots, so plus 6x plus the product of the roots, which is 9 minus 9 plus 1, so 10, right? This into ax square plus bx plus c. Now this has to be equal to what? The given thing, 3x power 4 plus 10x cube plus ax square plus bx minus 30. What do we need to find? Find the other roots. We don't need to find ab. We are not interested in that. So to find the other roots, we need to solve for this particular equation. So we need to find what a, b, c are. So immediately if you see x power 4 coefficient has to be the coefficient of x square into x square, right? X square from the first one, x square from the second one. So here we have ax cube, ax square into x square. So a has to be equal to 3, right? A has to be equal to 3. Now we know x cube. X cube is formed by x square into x coefficient and x into x square. What I mean to say is uh, x square from this one, x from this one, x from this one, x square from this one. So that is the only thing which will get us to uh, x cube. So in some sense, so 10 should be equal to x square into x here, which is 1 into b plus x here into x square here, 6 into a. Now a we know to be 3, so this is b plus 18. So b has to be minus 8. So we know b as well. C, how do we find? I mean, just multiply the constant terms. So, so what was it? 10c is equal to minus 30. 10c minus 30, that would mean c is minus 3. So the other polynomial, other factor of p, so the other factor of p of x is 3x square minus 8x minus 3, right? So what are the roots? Other roots. So we have written one root here. This is another root, and other than these two, the other roots would be x is equal to 8 plus minus square root of, what is the discriminant? 64 minus 4 into 3 into minus 3 divided by 2 into 3. So, okay, so that is 8 plus minus square root 64 plus 48. Is that it? Yeah, 12 into 3, 36. Oh, sorry. By 2 into 3. This is 10. So other roots are x is equal to 8 plus 10 by 6. 8 minus 10 by 6. So it is either 3 or minus 1 by 3. That's it. So I hope that clears this question. Yeah. So on to the next one. Please again pause the video and try this question on yourself, by yourself. I hope you have done that. So suppose f of x is equal to this and c and d are real numbers. Okay. Prove that if c is greater than 1 by 3, then f has exactly one real root. So what happens? What happens when a function or a polynomial is given to be cubic? So in a cubic, uh, either it has all three real roots. So cubic with real coefficients, I'm talking, right? All three real roots, or it can have one real root and two complex roots, right? And our question is asking exactly one real root. That means we want this to happen. So when does this happen? So if you look at the graph of it, if a cubic has all three real roots, it will be like this. But if a cubic has only one real root, something like, how would I say? Okay, so one case is x minus 1 whole cube equal to 0, this kind of a thing, right? This definitely has one root, but that does not mean it doesn't have other real roots. So something like x minus 1 into x square plus 1 equal to 0. So this is a cubic, yeah? This is a cubic, but it has only one root. So the graph of this would look something like this. It will be a strictly increasing odd function. Strictly increasing odd degree function, right? And it will be intersecting only at 1. Both will be intersecting only at 1, but you see the difference? I hope you do, right? So one thing you should be immediately able to observe is that this is strictly increasing. Yeah, whether it is like this or this, both are strictly increasing. Both are valid. Okay. So strictly increasing meaning f dash of x has to be strictly greater than 0, which implies here what is f dash of x? Uh, f dash, how would I find it? Yeah, f dash of x would be 3x square plus 2x plus c. Yeah, that would be 3x square plus 2x plus c greater than 0. When is a quadratic strictly greater than 0? Yeah, this is positive. No, the coefficient of x square is positive. So that means it would be something like this. It is not even touching. Yeah. So what is it? That means d has to be less than 0. A is greater than 0. Yeah, this graph is a is greater than 0. And this is minus d by 2a or 4a. This has to be greater than 0. So d has to be less than 0. So what is d? D is equal to 2 square minus 4 into 3 into c. Yeah, this is less than 0. That means 4 minus 4 into 3c is less than 0. So 1 minus 3c is less than 0. In other words, c is greater than 1 by 3. So if c is greater than 1 by 3 given, it has exactly one root. So one root happens only when, these are double implications. I hope you see that. This implies that, and other way around, you can go back here. This will imply that this is greater than 0, and this will imply that this is strictly increasing, and this will imply that it has only one real root. Understand? So I hope you understood how we do this. Yeah, that's it. Let's go. This is the final question for today, I think. Yeah. So just have a look at it and try to do it by yourself. Pause the video and try. Now, it is easy to find a polynomial root 2 plus 1, root 2 plus I as root, and p of x having real coefficients. Why is this not working sometimes? Okay. Having real coefficients. How do we find that immediately? Like if this is a root, we want real coefficients, what do we need to do? The other root has to be root 2 minus I. So root 2 minus I, root 2 plus I. So we can find a quadratic. What is a quadratic? X square minus the sum of the roots, 2 root 2 x plus the product of the roots, 2 plus 1, 3. This is a polynomial which has these roots. So this can be p of x. Right? So A is easy. Let's go to B. Find a polynomial q of x with rational coefficients. Here we just needed real. Here we need rational. Root 2 also cannot work. Right? So having least degree such that this is a root. So one thing is we can have x square plus 3 written as 2 root x, and we can say that if I square the whole thing, this becomes rational, right? So x square plus 3 whole square is equal to 2 root 2x whole square. This happens to be 4 times to 8x. So if I take my q of x to be x square plus 3 whole square minus 8x, this is rational coefficient with square root 2 plus I as a root, right? But we also need to show one more thing. It must have least degree. How do we prove least degree? So definitely we have seen that a square does not work. Quadratic does not work. So let us assume, suppose uh, a cubic polynomial has root 2 plus 1 plus I as a root. Cubic polynomial with rational coefficients. Rational coefficient. Right? That means the cubic, let's say ax cube plus bx plus c, bx square plus cx plus d, has to be, since one of this is a root, so x minus root 2 minus I, x minus, okay, some a into that. Let's take, monic polynomial, so we don't have to worry about that. X minus root 2 plus I, and let's say it has some real root. Yeah, let R be a real root. Okay, so how would that look like? That would look like x square. Okay, what was this? X square minus 2 root 2. Okay, did I take plus? Minus 1. Minus 2 root 2x plus 3 into x minus r. So how would that look like? X cube um, minus, so I want x square, so x into, so minus r plus 2 root 2 whole x, right? And yeah, I think that's pretty much it. That's what you'll get, minus r minus this. Yeah. And what's the coefficient of x? The coefficient of x will be, so suppose I multiply these two, so I'll get plus 2 root 2 r, and suppose I multiply these two, so I'll get plus 3 into x, and the last term would be minus 3r, right? So comparing the coefficients here, I hope you remember that b, c, d are rational numbers. That is the assumption. Our assumption is a cubic polynomial with rational coefficients, right? So that means if I comparing the coefficients, this has to be given that b is equal to r plus 2 root r, 2 root 2, sorry, and c has to be uh, 2 root 2 r plus 3, right? So is this sitting together? And 3r has to be d. So let's say I plus minus, I take care of that. So 3r has to be d. Here it gives me that r is equal to d by 3. So r has to be rational. But r is also this, b minus 2 root 2. So clearly this is irrational. Why is this irrational? Because b is rational and this is irrational. So overall r is an irrational. So this is a contradiction. Contradiction. Is that understood? So okay, so this is important to note, and once you noted that, now this contradiction to what? Contradiction to this assumption. This assumption is wrong, right? Okay. Now there is a C part. Show that any other polynomial f of x with rational coefficients and this has q as its factor, obviously. So I mean that's easy to see actually. Let's say f of x has, I mean the degree of f of x has to be greater than or equal to degree of q, right? Degree of q being equal to 4, right? Because q was by default the least degree such that this has a root. So that will imply that f of x can be written as some q of x into a of x plus b of x, yeah, where degree of this is strictly less than 4, right? Obviously. But if you take f of, and all are rational coefficients, all are rational coefficients, all are rational coefficients. So, but if you take root 2 plus I, you will get this is 0, root 2 plus I, this is 0, equal to, and this is also 0. But 0 is equal to what? B of root 2 plus I. But this is of degree less than 4. And we know that there exists no polynomial with degree less than 4, such that no non-zero polynomial, at least we can assume, that such that this is a root. So this has to be identically equal to 0. B has to be identically 0. So that means q of x is always a factor of f of x. So that proves it. Um, so that's it. That's all for today. I hope you enjoyed watching it. Uh, Take care. Bye. Hello everyone, how are you all doing? Welcome to this video. Today we'll be doing again a few geometry questions like we did in the previous one. We did triangle questions, but this time we'll cover more of circles in the CMI PYQs. And I hope you're enjoying this. And as I said in the previous video, I'll be recording on laptop for the next few videos, and I hope you don't mind that happening. All right, so and I hope my face is fine. This much size. That's it. Let's just begin. All right, here we go. So first question, pause the video and try it for yourself for once. I hope you have paused it. The only thing here which matters is the ratio, right? So first of all, since these two are parallel, these two are tangent externally, I would draw the tangent, exact tangent, and that would be parallel to BC, yeah, and that will keep on happening at each step, right? The circles keep on getting smaller, obviously, but what is the ratio exactly? If you see, what is an incenter, and especially since we have equilateral triangle, we have it easy, right? And in center, circumcenter, and what is that called? Centroid. Everything is the same in a circle, in an equilateral triangle. So in our given case, in this equilateral triangle, this R, let's say the side length is A. We will do the actual question, but I'm trying to generalize it. This R, if this is R, then centroid divides the median in 2:1 ratio. I hope you all know that. In any triangle, that is generally true. If this is a centroid, then this divides in 2:1 ratio, 2:1 ratio, right? So since in an equilateral triangle, centroid, in center, everything is the same, and medians and angle bisectors, everything are the same. We have that this is 2:1 ratio. So this is 2R and this is R. In other words, since this is R, this is R, this is also R. So if I am to draw another circle here, so let me try to make it a bit bigger. One circle is here, another circle is here. If the radius here is R, for this small triangle, everything is half, right? So this radius happens to be R by 2, right? Exactly for the same reason, because if this total is R, if this total is R indeed, this total height is R, but the R inside is, I suppose it's not R by 2, it's R by 3, right? Because this circle center, this divides the median in three equal parts. So this is R, this is R, this is R. So here it will be, let's say R1, R1, and R1. So 3R1 happens to be R. So R1 is R by 3. and so on and so forth. The same cycle continues for the, if this is, so R2 will be R by 3 square and so on, right? So we want what do we want exactly? We want the sum of the areas of all these circles. Yeah. So since we want all the sum, that will be pi r square plus pi r by 3 square plus pi r by 3 square. So if I take pi r square common, I'll have 1 plus 1 by 3 square plus 1 by 3 power 4 and so on. That will be pi r square into, if you look at this, this is 1 by 1 minus 1 by 3 square. Yeah, a by 1 minus r, that is this formula for infinite GP. This is basically infinite geometric series. So this happens to be pi r square, suppose it's 9 by 8. Now what is this r? We want to find r first of all. If the side length of an equilateral triangle is a, right, then the height is a root 3 by 2, and then this radius happens to be 1/3 of the radius of the height. So r is equal to 1/3 of a root 3 by 2, and it is 1/3 of, if you see, this is root 3. So 1 by root 3 to root 3 of a. And we have a equals to given to be 3. A is equal to 3. So in our case, r happens to be 3 by 2 root 3, which is root 3 by 2. So r square is 3 by 4. All right. So what does that make our answer? That will be pi into 3 by 4 into 9 by 8. So this is a huge thing. Pi into 9 threes are 27 by 32. Yeah, that's it. So I hope you enjoyed this question. Right. So next one. Let S be a circle with center O, and yeah, obviously pause the video and try it for yourself once. A and B are points on the circumference of S, and AOB is angle 120 degrees. For triangle this, we are given the circumcenter and the orthocenter. So we have to check whether these things are true or false. First of all, whether these two triangles are equilateral or not. You see, it will look something like this. This is O, this is say A, and this is say B. So that is 120 degrees. In general, how would 120 degree, like let's say C is somewhere, right? Let's not be concerned about our triangle, our circle as of yet. So let's say C is the circumcenter of AOB, and I have something like this. Because it is reflects this thing, obtuse angle triangle, circumcenter will lie outside. I hope you know that. Both orthocenter and circumcenter will lie outside of the triangle if this is there, right? Okay. So what do? We actually do take perpendicular bisectors and we take the intersection. So it will lie outside for a obtuse angle triangle. So this is OAB. So this is my circumcenter. So we are in equidistance with, so this and this both are R, circumcenter, right? And we know that this is also R and R, some R. We want to find what? If triangle AOC is equilateral. So let's do some angle chasing. Okay, first of all, before we do the angle chasing, what is this angle? How do we find this angle? See, if this is the center of a circle and these three are points, what is the central angle for the chord AB? That's what we need to find. But this is subtended angle, right? And we know the subtended angle is 120 degrees. And that means the central angle opposite to that would be double of that, 240 degrees. If this is 240, what is this angle? This is also 120 degrees. So let's have a good look at this. These two triangles are actually kind of congruent, right? So uh, you see that if I draw it like this, I think that would make some sense. And it will be like rhombus, I would say. Yeah, this is a rhombus. So if I join this, since these two are 120 degrees and everything, so this will be 60 degrees, this will be 60 degrees, this is also 60 degrees. Therefore, right? I mean, obviously this is 30 degrees, this is 30 degrees. So this will work. Uh, why are these two congruent, by the way? OAB, triangle OAB is congruent to CAB, CAB. Why? This happens because of ASA, right? These two angles are same, and then something else you can figure it out. These two angles are same, especially because isosceles. Anyway, so this is true. This is true. Acha, can we say something about ABD? So if you see, since my AOB looks like this, okay, let me remove this circle and I'll draw it here itself. Uh, so how do I draw perpendicular? I'll draw it like this, right? I'll take an extension and I'll draw, and that will intersect somewhere, right? Um, we want to find what is this angle basically. Okay, so what happens? Um, let's see. Very, very interesting. What is this angle? This is 30 degrees. Okay, this is 90. So let's make firm triangle. If this is 120 and this is this, so this has to be 60 degrees. So this is also 30 degrees. So this total angle is 60 degrees. Similarly, this angle is also 60 degrees. So this will also be 60 degrees. And this is D, by the way. So yeah, therefore ABD is also an equilateral triangle. Very interesting. Now, how do we figure out whether C and D lie on the circle, the circumference of S or not? So how do we do that? So let's make a few things. We know that this is O, this is A, this is B. Let's just draw something like this, C or C dash, right? Uh, if you see that this is 120 degrees, this is 240 degrees, and hence the subtended angle will be 120 degrees. So whichever point C or C dash or whatever you take, if it is making 120 degrees, that means it has to lie on this arc. And that will imply that C lies on S. And in a very similar fashion, if you look at this, we found that this is 60 degrees. That is half of this. So subtended angle, uh, subtended angle does lie on the this thing. And this is definitely a subtended angle. So the D dash has to lie on the circle. So D also lies on circle on S. So that's how you derive these two conditions. I hope that is clear. Yeah. Am I visible properly? All right. Next. Last question for today. Uh, pause the video and try it for yourself, and then we'll see. See, here the important thing to note is if you have an equilateral, not equilateral, what is a regular n-sided polygon, right? If you have a regular n-sided polygon, let's say I take any number of sides, it keeps on going till it is n. What is, so if I do like this, what is each central angle? Each central angle happens to be 2 pi by n because total is 2 pi and I'm talking in radians obviously. So 2 pi total angle divided by n equal parts, right? So if this is so, and let's say the circumradius of this polygon, it lies on circle of radius 1. So the circumradius is 1. So that means area of one triangle is, if you remember, it is, if this is theta, this is A, this is B, it is 1 by 2 AB sine theta, right? So here it is 1, 1 and 2 pi by n is 1 by 2, 1 square sine 2 pi by n, right? And this is the area of one triangle. So area of the polygon, area of the regular polygon is an is equal to n into 1 by 2 sine 2 pi by n. So it is n by 2 sine 2 pi by n. Yeah. So you can find A12. That should be easy. A12 is equal to 12 by 2 into sine 2 pi by 12. So that happens to be 6 sine pi by 6. Pi by 6 is 30 degrees. So 6 into 1 by 2, which is 3. No problem. But we want to find something crazy here. A 2014. See, here we have to use a little bit of calculus, right? So in second part, A 2014 is 2014 by 2 into sine 2 pi by 2014. So that's like 1007 into sine pi by 1007. Now, if you see n sine pi by n, as n grows, keeps on growing to infinity, right? As n increases, n into sine pi by n keeps on tending towards pi. This follows from the basic, sine x by x, as x tends to 0 tends to 1. This is what it follows from. I hope everyone is recognizing that. So since 1007 is a very, very big number, we can definitely consider A 2014 to be approximately pi, and we can actually say the integer part happens to be approximately 3, will be equal to 3. It's not approximate, right? So that's all for today. I hope you enjoyed this particular video, and meet you soon. Yeah. Hello everyone, how are you all doing? I hope everyone is doing good. I hope you've been following this CMI PYQ series. I didn't intend it to be a series. It just happened to be a series. I was trying to look for good questions, and CMI has very, very good questions, which are also related to Olympiads, right? So I wanted you to do that. And as I said in one of my previous videos, I'm at home due to some emergency, and I'm recording from here. But anyway, soon I'll be back in the studio and we'll make the large screen videos. For now, bear with me. Today we will do combinatorics problems, and enough of the intro. Now, let me just resize myself small enough. Yeah, that's good. Let's go. Okay. Let me grab a pen. That's it. So let S be the set of all 5-digit numbers that contain the digits 1, 3, 5, 7, and 9. So just pause the video, try this question. We need to find the sum of all the elements, and then we need to get this, right? So, it is easy to prove that it is divisible by this, always, right? No matter what is the condition for this. For this particular thing, find the sum. That is the important part. We can easily show that this is multiple of this, but let's just find the sum. So if you see, so the numbers are like 1, 3, 5, 7, 9. So each place carries on this digit only once, right? So how many times does, so how many such numbers are possible, first of all? Huh? 5 factorial numbers, such numbers are possible. Now, how many times does 1 appear in the first place? 1 appears in the first place 4 factorial times. So the number of times these can be changed, the 1 appears in first place 4 factorial times. How many times does the 3 appear in the first place? This will also appear 4 factorial times. So that will happen for each of these numbers, right? Now, so what is the sum of the digits in the first place? So if I'm adding number of ones plus number of threes plus number of 5, 7, 9, all of them, that will be simply 4 factorial into 1 plus 3 plus 5 plus 7 plus 9. And this happens to be what, 24 into, if I'm not wrong, this should be 25. And that would be, 24 into 5 would be 120, so 600, right? Now this is for each place, every single place. What happens when I do the sum of all numbers? That means the first place, which is 10 power 4, will have into 600. Second place, which is 10 power 3 into 600 plus 10 square into 600, 10 into 600, and 1 into 600. So obviously this is 600 into 11111, right? 10 power 4 plus 10 cube plus 10 square plus 10 plus 1. And this happens to be obviously a multiple of this, and 6666600. This is the sum. Yeah. So that should be very easy question. Now, you have to form a 7. Yeah. Like pause the video, try it for yourself. This is a good password question. Yeah. 7-letter password using 10 digits and 26 alphabet letters, right? Only lowercase letters are allowed. Okay. For example, this are valid passwords. Now, how many passwords can we make? This is a basic counting principle. The fundamental counting principle, if you use, each letter and each digit has an option of 5. So we have 36. So 1 has to be answered 36 power 7. Not 5, sorry, 7. So each letter and each digit has the option of 5 places. So yeah, so it's 36. And I hope you understand why that is so. A, B, C, D. A or B or C or D. So that goes on till 36. Okay. Now, I mean, if you look at it in the perspective of the places, this has 36 options, this has 36 options, this has 36, and it's an and in between them, right? So I hope you understand why this is 36 power 7. Okay, that is easy. That is the most very basic thing. But if you look at the second one, we want how many passwords such that at least one alphabet and at least one digit is there. So this is something we are entering the realm of principle of inclusion exclusion. This whole question is based on principle of inclusion and exclusion, right? Uh, so if you look at, so total, so how do we find that? At least one. So whenever you see the term at least is same as total minus none, right? At least one alphabet meaning total minus no alphabets at all. That means at least one alphabet will be there, right? I hope that is clear. So that means total is 36 power 7 minus at least one alphabet. So minus all the alphabet. Let's remove all the alphabets and whatever is left. That means we'll be left with 10 digits only. So digits power 7. Minus, we are also removing the case where there are no digits at all. So if there are no digits at all, we are removing the case where we are using only alphabets. So this is the answer for the second question. And this is purely principle of inclusion exclusion, right? So I hope that is understood. Now second question done. Let's just take it just for our convenience. How many passwords are there with at least one consonant? Consonant is the letter which is not a vowel, right? Consonant, vowel, and one digit. So we are dividing the alphabet thing into two different parts now, right? So this is classic inclusion exclusion principle. So uh, so at least one. So at least one consonant, one vowel, and one number digit, right? That means uh, total minus, let's remove one consonant, minus with no consonant, no consonant, no vowel. Okay, okay, so let me write it down carefully. No consonant or vowel minus no uh, right. So this will give us at least one, meaning out of the total I'll remove the cases where there are no consonants, right? No consonant. I'll also remove the case where there are no vowels. I'll also remove the case where there are no digits, right? But if you see, if I'm removing this, when I'm removing no consonant and no vowel, that means I'm removing something twice. What am I removing twice? Something twice, which is only digits. I have to add once. And here I have to add only vowels once. And I have to add only uh, consonants once, right? And overall, again, I have to subtract something, and that would be uh, no consonants, vowels, or digits, none, which is basically zero. So this does not hold that much value, right? So what would be the total? Total will be 36 power 7 minus no consonants. No consonants meaning how many options do we have? That means only vowels and digits. Only vowels and digits. So what is that? Only vowels and digits would be vowels are 5, digits are 10. So 50 power 7 minus only no vowels meaning 21 plus 10. So 31 power 7 minus no digits meaning only uh, only consonants and vowels, which is basically 26 power 7, right? Plus only digit 10 power 7 plus only vowels 5 power 7 plus only uh, consonants. What is this? 21 power 7. So that's it. And no consonants vowel. This does not make any sense, right? So let's just remove it. This is the answer for the third one. Yeah. And the fourth one is also very similar. I'll actually leave it to you as homework. This one, right? Fourth one is a homework. We have done this. This is homework. 12 additional characters. Now we are having at least one, at least one, at least one in everything. So yeah, that's the thing. I think it should be easy to solve. All right. So last question for today. It's a very interesting one again. Map B set of all functions this to this, right? Map N is a set of all functions from the set of 1 to n to set of 1 to n. F and G belonging to this, we define this, um, uh, f of G, right? Which sends x to this. Read the question, try the question on yourself, by yourself. Okay. I hope you paused the video and tried it. We need to show A is easy actually. If for all f of x this is happening, then this is never going to happen, right? So let's say f of f is equal to f, right? And f of x is equal to y, which is not equal to x. But f of x is equal to f of x, right? Because of this. But f of x is equal to f of y, and f of x is equal to y. So we are getting f of y is equal to y. But f of x not equal to x for all x. So this does not happen. So this is a contradiction. That implies f of f is not equivalent to f. Is that clear? So this is the way you prove contradiction, which is normal. Now we want to count the number of functions such that f of f is equal to f. Now you see, somehow f of f equal to f has something to do with whether you have f of x equal to x or not, right? B. So these are called, let's say these are called fixed points. Yeah, fixed points. So you'll see that okay, so these are fixed points. Why is that important? So let's say f of x is equal to y and x is not equal to y. And f of x happens to be f of y, but this happens to be f of x, which is y. So f of y has to be y. So y has to be implies, so this whole thing f of x equal to y implies y is a fixed point. That implies that we are interested in finding f should be defined on 1 to n to set of fixed points. This is set of fixed points. So whatever value f of x takes, it has to be a fixed point at the end, right? So the image is a set of fixed points. So if we figure out how many sets are possible and for each set how many such functions are possible, we will be able to figure out how many functions are of the type f of f is equal to f, right? This is directly related to this set S, which is set of fixed points, right? So how do we find that? So let's say S has k elements, right? And obviously k is less than or equal to n, greater than or equal to 1. Yeah. Uh, and that is image. So for each k, how many S is possible? Number of S is equal to nck. Out of these n, 1 to n, we are choosing a small set of k and we want that to be S. And for each S with this, how many functions are possible? How many functions are possible? Uh, so for k values of this, we will give one of the k, this thing, right? 1 to n to S. So whatever elements in S for x belongs to S, f of x equal to S x, right? That is the definition. But for x belongs to S complement, which is 1 to n, minus s. What do we do? There will be n minus k terms. What do we do with this n minus k terms? They have to be assigned some value in s. That means in s, if there are s is suppose a1, a2 till ak, right? Each of them have n minus k options. And thus creating that many functions. So we will get k power n minus k functions. So for this cardinality of s being equal to k, we will have number of functions such that f of f is equal to f is equal to nck into k power n minus k, right? And this k will vary from 1 to till n. So find. So total number of functions is equal to summation nck k power n minus k. So I hope you will be able to find that using your combinatorics knowledge, right? K varies from 1 to n. That I leave it to you as homework. So I just wanted to get to this point. All right. So I hope you found it interesting and helpful. Tell me in the comments this particular answer of this particular question. I'll be totally thrilled to read them. Right? Chalo. Bye. Take care.
Hello everyone, welcome to this video. I really hope that you understand the importance of this solving the PYQs because you'll get the real feel of the examination. So yeah, anyways, read the question, pause the video, write for yourselves, and there we go, we'll begin. We know how the general solutions will look like, and we will use the fact that we have it in the denominator, so this will be 0. That was an easy thing to solve. Hello everyone, welcome to this video. Let's continue our preparation towards CMI with the CMI PYQs. I hope you realize the importance of this. I really hope that you understand the importance of this solving the PYQs because you'll get the real feel of the examination, right? I hope you're not missing out on any session for this. Even though the name is CMI, ISI, same thing. It helps you overall in mathematics. So one question at a time. 2 questions per video, 3 questions per video. We're going to cross it like this. So before we begin, I want to let you know that if you're preparing for IOQM, guys, we have launched a new course, right? New batch. I hope you join that. I hope you have watched at least the announcement video. You'll learn a lot in the batch. You'll be interacting with me. It will be live sessions, more than 45 live sessions over the course of 3.5 months. We will be close friends. I really hope we become even more close. And that's pretty much it. Please go and watch the session. Now, something wrong with this pen. Yeah. So yeah, anyways, so read the question, pause the video, try it for yourselves, and there we go. We will begin. Okay, how do we solve this thing if we didn't have the powers, right? Let's say I want to solve it for 20 alpha plus 24 beta. How do we solve this? This is number theory stuff, guys. This is called a Diophantine equation. This is a linear Diophantine equation on 2 variables, easiest of the Diophantine equations. Yeah, you'll cry when you understand what are the difficult types of Diophantine equations look like. Like, come on, if you go to CMI, if you go to ISI, you're going to solve, yeah. 2024. So how do you solve this first? Step 1. We know how the general solutions will look like, and we will use the fact that all these things are positive integers yeah, and k and n are particularly greater than 1. All right. So what do we do? What do we do? So first, I will cancel out 4, right? This is 4 into 6. This is 4 into 5. This is 4 into 5, 0, 6. All right. So I have 5 alpha plus 6 beta. Now, while solving Diophantine equation, we understand that once you have one solution, you can derive multiple solutions from that point onwards. So let's say we have a comma b is a solution. You'll see that a minus 6 and b plus 6 is a solution. B plus 5 is a solution, sorry. Or a plus 6, b minus 5 is a solution. If this is a solution, then these two are solution. In general, if you want to write a minus 6l, k is used. So a minus 6l and b plus 5l are solutions for L belongs to Z. Z is set of integers. All right. All these are solutions. Every solution can be written like this. So how do we prove that? How do we prove that? Proof. Now say a comma b is a solution and a dash comma b dash is another solution, right? That would imply that what was that, 5a plus 6b equal to 506 and 5a dash plus 6b dash is equal to 506. So if you subtract them, it will be 5 into a minus a dash, 6 into b minus b dash equal to 0. So yeah, if you take 6 to the other side, so 5a minus a dash will be equal to minus 6b minus b dash. So if you cross multiply these things, so you will get a minus a dash by minus 6 is equal to b minus b dash by 5. You can take this to be some k, right? So you will get a dash in terms of a minus 6k and b dash in terms of a plus 5k. Understood? So it is that simple, and this we already did but in exams, is it important to write this? It is, since it is a small thing and you get a lot of time. If you have a lot of time, you can write it down. Otherwise, you can generalize it and write the generalized form very, very clearly. All right. So we know that if a comma b is a solution, every other solution will look like a minus 6k, b plus 5k. All right. Now, so we need one initial solution. What would be one initial solution if 5a plus 6b equal to 506? Obviously, one can directly see a equal to 100 and b equal to 1 will be a solution. And we want to find a such that a is some x power k and b is some y power l or n or whatever, right? Such that k and l are greater than 1. And x comma y are positive integers. All right. So all these things should be satisfied. Acha. Here, this k cannot be negative. If I take k negative, I'm just subtracting. So my initial solution is 100, 1. I cannot decrease my y quantity. I cannot do minus 5 because I'll get negative quantity, which is not allowed for me. So I'll keep on increasing 5. So I have to decrease 6 multiples of 6 in the first term. So we will check that. 100, 1 is a solution. So we'll do minus 6 plus 5. So this will be 6. 94. $76, 21. Maybe one more I'll write here. 70. Right. Oh, what? If I remove 6, if I remove 6, it's 76. If I remove 6, it's 70. How many 6s did I remove? 5. Okay. Makes sense. So 20, 6 here, 64 and 31. Add 36, 6 square, but here we'll not get something. So we are missing out by one term here and there sometimes. You're getting 16 here, you're getting 36 here. You got 64 here, but it's not that. Anyway, so if you remove 6, it will be 58. Yeah. And then it will be 52. Here it will be 41, 46, 51, 56. So let's keep it here, 46. Oh wow, we got both 46. Interesting. So you'll get 42. Oh, you'll get 40. And then here you have 34. I can get another one. I can get 28. So and what, 61. So I'll have 66, 71, 76, 81. So I hope to get something here. All right. So what is the last one? What is the next one? 22 and 16. Again missed by one of those. 10, 4, 4, 81. That works, right? So it is 2 square and this is 9 square or 3 power 4 or whatever. So yeah, so this is one solution and this is another solution because 100 works. 100 is 10 cube, 10 square, and 1 is anything, 1 power anything you can take. So we have two such solutions for this. So you can say this, that 20x power k plus 24y power n equal to 2024 will have two solutions. X is equal to 10, k equal to 2, y equal to 1, n can be anything, right? And this is one. Second solution is x equal to 2, k equal to 2, y equal to 3, n equal to 4, something like that, right? So this will work. There you go. These are the solutions. Let's go to the next one. Now again, pause the video, try it for yourself, and yeah, of course, pause the video. Okay. This is a very vague question, all right? This is a kind of unusual question to get in CMI examination. And they don't really expect you to give exact answers either. So they want to check your ability to understand the concepts. Do you understand functions? Do you understand the graphs? Do you understand how logarithms work? Can you approximate properly? Yeah, that's what they are testing you in this question. So let me know if you could solve this in the comments before I begin to solve it. All right. Next. So what do? First of all, we want to find g of 1000. So first of all, let's, before all that, what is this? This is a quadratic, right? That is a quadratic. So just look at this, t square minus 1000 t, right? So I will need to add 500 square, and I'll need to subtract 500 square. So this is 10 power. Do you understand what is 10 power 1000? 1 with 1000 zeros. It's such a huge number. It's a very big number, right? It has nothing to compare in this range of 10 to 1000. The whole question talks about this range only. All right. So let's only talk about that. Minus 500 square. So 500 square is nothing. Yeah. So this is t minus 500 whole square plus 10 power 1000 minus 500 square. All right. That is the quadratic. Now, what would be g of 1000? G of 1000, forget g of 1000. I'm just talking about what would be the function when x is between 10 to 1000. Because what is g of 1000? This is simply equal to 10 to 1000 log base 10 of log base 10 of the t square minus 1000 t plus 10 power 10,000, 10 power 1000 dt, right? So in this range, what would this be? Do you understand that this is huge compared to this in t belongs to 10 to 10, 10 to 1000. 10 to 1000 is nothing for this. This is huge. All right. So if you have to approximate it, I would do this. Although they don't expect you to do that, they just expect you to say that this is huge. So this will overtake the whole thing. So the logarithm of base 10 of this thing will be approximately simply 10 power 1000. It will be approximately this. So basically you can simply write this down, that this is approximately integral from 10 to 1000 logarithm of this dt. So this will be approximately 10 to 1000 of log base 10 of what is this? This is 1000, right? Sorry about that. And if you take log again, you'll get 3 dt. So you will basically get 3 into 1000 minus 10. That is the approximate answer. Approximately g of 1000 would be this. All right. Unless you are given some crazy high quantity of g to be found, it is unnecessary and it will be exactly this. But if you are not convinced by this, I will give you a very, how do we even approximate it? So you should know that log, or rather base e of 1 plus x, there is an expansion for this, right? So 1 minus x plus x square by 2 minus x cube by 3 and so on, right? There is an approximation when x is very close to 0. So if I give you log base 10 of something, some quantity, first of all, you will have this huge quantity plus t square minus some 1000 t, right? This will be first of all 1 by natural log of 10 into natural log of 10,000, 1 plus t square minus 1010 by 10 power 1000, sorry, 10 power 1000. So this is very, very close to 0. This is going towards 0. It is this close to 0, right? So this whole thing, it becomes 1 by natural log 10 into natural log 10 power 1000 plus natural log of 1 plus this small quantity t square minus 1000 t by 10 power 1000. Now you can approximate this to, oh, by the way, I don't think there is 1. There is no 1 here. It is simply approximately 1. So this will be approximately equal to t square minus 1000 t by 10,000. 10 power 1000, sorry. Right, this will be approximately this. This is purely calculus stuff. If you are not able to follow, I don't mind. So this is 1000 plus, this is approximately 1000 plus t square minus this by 10 power 1000. Right? Now you want to take logarithm of this again with respect to this. So you will again take 1000 common, you will divide it, that will be even more smaller. You will get 3 plus something very small. So it is again at the end approximately equal to 3. And that's what they expect you to answer, honestly. All right. And what was the next question? Part B and C, actually both together, I think you can answer them. What is B and C? Let's have a look. We want, whoa, calculate the quantities below and approximate. Oh, acha, first, oh, we forgot to do A. So we started doing B. So we already did B, but what is the domain of this? So obviously, this is always greater than 0, right? That is always greater than 0. I hope you see that, because I just wrote this, you see. So this is always greater than 0. So domain is the whole R. Domain you can take to be the whole R. We don't mind, right? Yeah, I hope you understood that. Now C and D together we can say, so we want x in between 10 to 1000 such that it has maximum slope. So slope, right? We are interested in slope. So what is the C and D actually? What is g dash of x? Using one of the fundamental laws of calculus, fundamental theorems of calculus, you will get this to be log base 10 of log base 10 of x square minus 1000x plus 10 power 1000. Now, obviously, in and x belongs to what? 10 to 1000. We want the greatest value. What is the greatest value of this? We know that I just wrote this down. This can be written as x minus 500 whole square plus 10 power 1000 minus 500 square. So you see, log is an increasing function. Log base 10 is an increasing function, right? Since it is an increasing function, wherever this is increasing, wherever this is maximum in this range, this will also be maximum. So it will be maximum at x equal to 1000, right? In this range. And it will be minimum at x equal to 500. And you can find the approximate values as well. I don't think that would matter, but both will be nearly 0. Nearly 3, I'm sorry. Nearly 3. Right? And what else do we want to find? Log x by gx when x is tending to infinity. So we know what to do. We know that g of x is increasing, right? And ln x is also increasing. We can use L'Hopital's rule. So for finding part E, we want to find limit x tends to infinity natural log of x divided by g of x. Now, since g of x is tending to infinity, we can use L'Hopital's rule. L'Hopital rule. So I will write this as equal to limit x tends to infinity 1 by x by g dash of x. Now this is interesting because x tends to infinity 1 by x g dash of x. We see that obviously, you see this is g dash of x, right? This is also increasing, na? This is also an increasing function. As x increases, this will be increasing. So it is tending to infinity, and we have the denominator. We have it in the denominator, so this will be 0. That was an easy thing to solve. So I hope you understood this question. I hope found it interesting. Take care. Bye-bye. Say something in the comments. Hello. How are you all doing? All good? So welcome to this video. Quick update. If you have not watched the IOQM batch launch video, please go and watch it. Yeah, we are launching a new batch, and I hope that you will be interested in that if you are at all preparing for IOQM. And we are planning this specifically for 11th and 12th students, so that you will find time. The timings are 9 p.m. to 10:30 p.m. So in the night, if you are willing to study, you're welcome for that batch. Now with today's session, in this, I hope you're all preparing for ISI CMI as well. Whoever is preparing this video will be for you, obviously. And what else do I say? Just prepare, keep preparing, do PYQs, only PYQs. This small, we have very small window right now, right? We have maybe a few weeks at most. So keep preparing PYQs. And I'm bringing PYQs, and I'm bringing only a few. The idea is that it will show you where you are lacking probably. This question is not, it won't tell you that you'll solve a bunch of problems with this, but it will show what should you be focusing on. So pause the video, try this question for yourself, and then I will start solving from my side. Okay, I hope you have tried it. See, the moment they give you this kind of an expression, our mind immediately goes into, how do I put this here, right? That was my first thought also, which is unfortunate. It shouldn't be the case. How do I put this here? That's not our concern. Our concern is how do we get from here this expression to this expression. That is the important thing. Okay, as usual with almost every functional this thing, we will put some values. Let's say we put m equal to 1. All right. So if I put m equal to 1, that would mean g of n plus 1 is equal to g of n plus n into n plus 1 plus some g of 1, right? And we can write this as, I'll just take this to the other side, so I'll get something like g of n plus 1 minus g of n is equal to n into n plus 1 plus g of 1. Now, this is, this depends on n, and this is a constant. We will figure out what g of 1 would be. G is functions from this to this, right? Z plus is basically positive integers. Oh, it is written. Z plus is set of positive integers. So g of 1 would be, let's say g of 1 is equal to some k. All right. Okay. It doesn't matter. G of 1 can be anything. So how do I do this? This is basically a telescopic, right? So we have g of n plus 1 minus g of n is n into n plus 1, or rather I would like to write it as something else. N into n plus 1 will be n square plus n will be 1, right? So I'll write it as n square plus n plus g of 1. So putting n equal to 1, n equal to 2, and so on till n equal to n itself. G of 2 minus g of 1 is 1 square plus 1. G of 3 minus g of 2, 2 square plus 2 plus g of 1, and so on till g of n plus 1 minus g of n, n square plus n plus g of 1. Now if you add all of these, you will see that g of 2 gets cancelled, g of 3 will get cancelled here, and so g of n will get cancelled. So g of n plus 1 minus g of 1 will be equal to, this will be summation I square, I varies from 1 to n, plus summation I varies from 1 to n, plus how many times are you adding this? You are adding this n times. So yeah, we have g of n plus 1 minus g of 1, I will write it that side, that will be equal to summation I square, I varies from 1 to n, I varies from 1 to n, g of 1 into n, but I wrote one of these here, so this will be g of n plus 1. Right, and we know this answer, this is n into n plus 1 into 6, 2n plus 1 divided by 6 plus n into n plus 1 by 2. So plus some constant into n plus 1. Yeah. So anyways, this is a cubic thing. I can take few things common. I can take n plus 1 common. Let's say I take by 6 common. So it will be n into 2n plus 1 plus 3n plus 6k. Right? And this is a quadratic. So this is g of n plus 1. I can just replace it with g of n. That will be n by 6. N minus 1 into 2n minus 1 plus 3n minus 3 plus 6k nonetheless. Right? Where k is belonging to some z plus. So it can be anything. So for every g of 1, you will get a specific gn. Right? G of 1, the initial point, whatever you get, based on that you will get a specific gn. So yeah, this is of the form, this is of the form summation ci n power I varies from 0 to 3. It is at most a cubic. So yeah, and you can figure out corresponding ci's from there. You have to write that. So I'm leaving certain parts for you to solve. All right. So yeah, that's it. Easy question. Yeah, again I'll get out of the frame, pause the video, try this question, and let us get back to it. Okay, I hope you have tried it. Suppose that for a given polynomial, which is biquadratic or quantic, what is it? Let me know in the comments. So there is exactly one real number r such that p of r is equal to 0. And we'll see the rest of the questions. But the important thing lies in the first statement itself. If a degree 4 equation has only one real root, right, that means p of x, I can write it as x minus r into a cubic, right? This is a cubic. Now a cubic, the roots of cubic are of two types, either all three real roots, right, or one real root and two complex roots. This is possible, either that or this. If all three are real roots and we know that there is only one real root, this case would imply that all three real roots are also r only. Only r is the root. So that means either it is x minus r whole square, or it is, I don't know, x minus r whole power 4, sorry, not square, or it is x minus r one real root. This one real root again has to be r only. The other two complex roots can be anything else. So it is x minus r whole square into x square plus alpha x plus beta, something like this. right? Since A, B, C, D are used, I am using alpha, beta. So these are the only two cases which is possible, right? Now, case 1, let's take case 1. P of x is equal to x minus r whole power 4. That means this is x power 4 minus 4rx cube plus 6r square x square minus 4r square r cube x plus r power 4. Okay, either that. In this case, if you see, we wanted x power 4 plus ax cube plus bx square plus cx plus d, right? And in case A, B, C, D are rational. In question A, like we have two questions over there. So what does the first question say? Show that if A, B, C, D are rational, show that R must be rational. So this we have to show in both case A and case B, case 1 and case 2. So case 1 is this, case 2 is that, right? So let's see. If A, B, C, D are rational, that means A is rational. So minus 4 into R equal to A is rational. So obviously R equal to minus A by 4 will be rational. So that was easy to see, right? The problem comes with case 2, right? We'll show part B. Part B is actually simpler in some sense. Okay, case 2 is P of x is equal to x minus r whole square into some quadratic. I'll just write q of x here. All right, this is a quadratic. Quadratic with imaginary roots. Imaginary roots. है ना? So what do? There is a hint given. There is a hint given. You can try to write this as x square plus alpha x plus beta and then compare the coefficients. You can try that. That is your choice. Even I did the first the same thing. But consider the roots of the derivative p dash of x. Right? So what is p dash of x? P dash tells you, okay, let's just first try to draw a diagram. If it is not of the form x minus 4 whole square, x minus r whole power 4, this would be like this only, na? Wherever it is, it will be almost like x, a parabola only, right? But it is not a parabola, but it looks like one. Okay, but what happens if it is like this? P of x is of the form x minus r whole square into q of x. This has imaginary roots. It will look something like this. It will go here. It might look like this. You understand? Since it is a biquadratic, it will be facing, it will be going to infinity only. But it might take some curves, but it will have exactly one root here. This is how I would imagine this would be looking like, right? Now, if you look at p dash of x, where would be the roots? One root here, and r will also be, x minus r will also be another root. So here also p dash is 0, here also p dash is 0, here also p dash is 0. That is important to note. Even if you look at it algebraically, you will see that this will be x minus r whole square into q dash of x plus 2x minus r q of x. So that will be basically x minus r into 2q of x plus x minus r q dash of x. You see, q of x won't have x minus r as a factor. You understand? So definitely x minus r is a common factor of p of x and p dash of x. But you see that it cannot be x square here, so it has to be the highest common factor as well, right? So this has to be HCF. So x minus r is equal to GCD of p of x comma p dash of x. Now what does that tell you? Interestingly, you see p of x has rational roots and p dash of x also has rational roots, right? Obviously. And to find GCD, how do we find GCD of GCD is found through which method? Euclidean method, right? Euclidean method. How do you do that? So you just do the division and the Euclidean algorithm basically. So once the same, yeah, we do that with integers. It can also be done with the this thing as well. What do we call it? Polynomials as well, right? So we are doing it with the polynomials now. So how do we do that? So like we did not work on it right now, but you know that x minus r will be a linear combination of p of x and p dash of x, right? Linear in the sense linear polynomial combination. There will be x, the polynomials as multiples. So basically I am saying that will be equal to and these two have rational coefficients, so it must be having rational coefficients. You understand? By linear combination, how do we get to this conclusion? So this also has rational coefficient, that means r has to be rational. You may try with other methods of doing this, but this is something which I have found to be a very straightforward and fascinating thing once you understand it. Yeah? Okay. So we proved part A. If they are rational, then we know that it must be rational. For both cases we have proved. How do we show that if A, B, C, D are integers, then how do we show that R has to be an integer? First of all, if A, B, C, D are integers, they are rationals. So R root of x square plus ax plus x power 4 plus ax cube plus bx square plus cx plus d. Root of this, that means if a, b, c, d integers implies r is rational. Any problem with that? I hope not, right? So that means I can take r to be some p by q, right? This is a root, so p power 4 by q power 4, p cube by q cube, p square by q square, c p by q plus d cube, p d and nothing. So what is the thing? What is the, how will we do this? What is the condition on p and q? First of all, this has to be rational such that p comma q are co-prime. There is no divisor greater than 1 which divides both p and q. Okay, now this is equal to 0 since this is a root. We have to show that q is 1. That is the goal. The goal is to show that q is 1. Okay, so let's see what happens. If I multiply q power 4, then I will have p power 4 plus A into P cube Q plus B into P square Q square C into P cube. So what am I doing? I am multiplying Q power 4 to the whole thing. So I'll get this plus dq power 4. Okay. You see that I can take q common here. So I can write q into something is equal to minus p power 4. How is that possible? And we know that q and p, the GCD is 1. That implies that q divides p power 4 only if q is plus or minus 1. There is no other choice. If q is not plus or minus 1, this is not possible at all. So this is the proof. This is a very standard thing which we do in theory of equations actually. So yeah, I hope it was understood and it was fun. 21 minutes. Damn. So I hope it was done. Crazy. Bye bye. Take care. That's all for today. Hello everyone, welcome to this video. I hope, oh, dude, I was about to fall. I hope you're doing well. So yeah, we'll continue our CMI PYQ preparation. Okay, one thing, we have launched IOQM preparation batch, right? Weekdays batch, Tuesdays, Thursdays and Saturdays, 3 days a week from 9 p.m. to 10:30 p.m. in the night if you're preparing for examination, to prepare for out of the box thinking. So you can spend your daytime, the whole rest of the day for JEE preparation or something, you might be busy. But in the night, if you want to prepare for IOQM, please take the batch. We'll meet there 3 days a week in the night. All right. So now that that's out of the way. Whoa, what's happening? Dude, come on. Okay. Okay. So yeah, read the question, try it for yourself, pause the video. It is a very interesting question if you know complex numbers. Very, very fascinating. It uses trigonometry, it uses whatnot, man. This is a very good question. Okay, so what do we have here? Find all the complex solutions of this, and then later we are asked to generalize it for any n. Right, here we have specifically z power 6, here we have z power n equal to that. So let's go to this and let's formally do it. What is z power 6 plus that? So suppose z was equal to r e power I theta, right? Then we will have z power 6 will be r power 6 e power 6 I theta. And I hope we all know what this r is. This r is strictly greater than 0, right? If z is not equal to 0, this is strictly greater than 0. So definitely one of the solutions is z equal to 0. That is often called a trivial solution. So we don't want the trivial solution, right? So I mean, fine, that's obvious. Okay, now that that's out of the way, we'll see what other solutions we can get. And z plus z bar will be 2r cos theta, because this is 2 times the real part of z. And since we are writing it in the polar form, we'll have this is the real part. So what do we have? Putting these two together, yeah, we will have r power 6 e power 6 I theta is equal to 2r cos theta, right? Now, okay, you see, since I'm taking r not equal to 0, I'll have r power 5 e power 6 theta I is equal to 2 cos theta. So this is a completely real number. So this has to be a real. And the only real values it can take is +1 or -1. So let's write that. So case 1, we have e power 6 theta I is equal to 1 and r power 5 is equal to 2 cos theta. And the other case will be this is -1 and r power 5 is -2 cos theta. So that is possible. We will do that later. So first, this is the case 1. So how do we solve case 1? Okay. So first of all, here we have cos theta is equal to r power 5 by 2, which is positive. So cos theta is positive. And what are the possible values of theta here? We know that 6 theta will be of the form 2 pi k. Only then we have it to be possible. And k is between what would that be? 0 to 5, right? Isn't it? Because yeah, because we take theta is equal to 2 pi k by 6. So it can be at most, otherwise it's repeating again. Yeah, that makes sense. All right. So this will be theta is equal to pi k by 3. Even this can be noted. All right. Now what do? We have this and k has a particular range and we have this, right? When is cos theta positive? If you know the diagram ASTC, right? All students something teacup, I don't know, something. I don't remember that. It's just that everything is positive here. Only sine is positive here. Tan is positive here. Cos is positive here because cos is positive even in the negative angle. That's what I remember. So anyway, so cos theta is positive here and here, right? So that means theta is either positive, theta can be equal to 0, strictly positive, but less than pi by 2, or theta is strictly greater than 3 pi by 2 and less than or equal to 2 pi, right? So these are the positive values, possible values. Now we will, include the both. So what do? Pi k by 3 is either strictly greater than 0. So case 1, part 1, and strictly less than pi by 2. So what will that give me? K is greater than or equal to 0, but strictly less than 3 by 2. That gives me k equal to 1, right? Only, 0 and 1. 0, 1. I should write 0, 1. Or what is the other possibility? Pi k by 3 is strictly greater than 3 pi by 2 and less than or equal to 2 pi, right? And so that would mean k is strictly greater than 9 by 2 because I can cancel out pi, right? And k is strictly less than 6, less than or equal to 6. Well, you can take anything. So k can be equal to, if you take 0, I don't think we will need to include 2 pi, right? Because 2 pi is simply additional thing. So I'll take strictly less than 6. So 9 by 2 is what? 4.5, right? So k is strictly greater than that, so it can be 5. Oh, and we are not taking 6, so it is only 5 and 0 comma 1. So we have three values of k. We have three values of k. So we got theta is equal to either 0, which is basically saying for each value of theta, we'll get a particular value of r as well, right? And remember, this is only case 1. In case 1, I have theta equal to 0, 1, and 5. We'll do case 2. Similar, very similar. So what is case 2 saying? That e power I 6 theta is minus 1, and what else? What was the other one? R power 5 was minus 2 cos theta. So I want you to see that minus 1 is, what is the basic minus 1 thing? E power I pi, the most famous. This is equal to e power I 6 theta. So 6 theta can be written as pi plus 2 pi k. Yeah? Again, the k has to be, it can be greater than or equal to 0, less than 6, something like this. So and this is, I'll write 2k plus 1 into pi by 6. So theta is this. And here we have that cos theta is equal to minus r power 5 by 2, which is less than 0. Because r is always positive, remember. R is the absolute value of z. So it is, r is the distance. Distance is always positive. It cannot be negative. So yeah, so cos theta is negative in these two, right? That means either theta is greater than pi by 2, because at pi by 2 it is 0, greater than pi by 2, less than or equal to pi, yeah, or theta can be greater than pi. Oh, so basically I can include all these, right? So I can take this strictly between pi by 2 and 3 pi by 2. That would be better, because it's basically this whole range of semicircle angle. So I'll do it right here itself. I need not go to another slide. So 2k plus 1 pi by 6 is between pi by 2 and 3 pi by 2. I'll remove the k. I can remove one of the 2's. So if I multiply 3, it will be less than 9. So 2k plus 1 greater than 3. So if I remove the 1, it will be 8. 2. If I divide by 2, this will be greater than 1, less than 4. So k can be only 2 and 3. So yeah. So overall, from case 2, I will get k equal to 2, 3. From case 1, I got k equal to 0, 1, 5. So interestingly, we get all k's except, 4. 1, 2, 0, 1, 2, 3, and 5. Yeah, so only 4 wouldn't work. Interesting. Now let us try to generalize it. So what is the generalization? Part B, we want to have z power n equal to z plus z bar, right? So what would that directly imply? That would directly imply that r power n e power I n theta is equal to 2r cos theta, isn't it? So again, we will get two cases. Case 1, okay, first of all, we are removing, so first case is z equal to 0, right? This is trivial case, I'm removing that. Other than that, if you cancel out these two, so you'll have something like this. So basically, e power I n theta equal to 1 and r power n minus 1 equals 2 cos theta, right? This is case 1. So what do I do here? Obviously, n theta has to be 2 pi k. So theta is equal to 2 pi k by n, and cos theta is r power n minus 1 by 2, which is positive. So theta has to be either theta has to be either greater than or equal to 0, less than pi by 2, or theta has to be less than or equal to 2 pi and strictly greater than 3 pi by 2, something like this. And if you put these values here, immediately you will get one thing. So in the first part, yeah, in the first part, what do you have? It's just translation and everything. 2 pi k by n greater than or equal to 0, less than pi by 2. This is giving me k is greater than or equal to 0, strictly less than n by 4, right? Or the other thing you will get is theta is strictly greater than 3 pi by 2. So 2 pi by k by n, this is less than or equal to 2 pi. So 2 pi gets cancelled. So you have k less than or equal to n, or maybe I have to remove 2 pi because I'm including 0, strictly less than n, but strictly greater than 3n by 4. So here you see we have n by 4 term. The case will be different if n is a multiple of 4, right? Because if you have n equal to 4k, k is already used, so 4l. So it is again 2 cases, sub cases. So 1a, I think, whatever. This you'll have k is greater than or equal to 0, strictly less than l. So that will be 0, k will be 0, 1 till l minus 1, right? And it would be something different even if you had plus r by, it would be nothing different even if you had this. But for the other case, because you also had k has to be less than n, but greater than 3n by 4, and that would be 3l plus 3r by 4. Now things will change. If r is 0, the values of k will start. Oh, what is happening? Something problematic. No, nothing problematic. All right. So k will be starting from 3l plus 1, right? Because it is more than that. 3l plus 2, and so on till n minus 1, which is 4l plus r. I don't know how is it different. Would it be different if r was non-zero? I don't think so. All right. And the other case I want you to solve by yourself is e power I n theta equal to -1 and r power n minus 1 equal to -2 cos theta. So I give this as a homework to you, right? This is the homework. Okay. Let's go to the next one. Pause the video and try this for yourself. I know it looks scary and all that. Okay. So I hope you gave it a little try. Now, let's just see what happens to the function around 3000, a little bit above and a little bit below, right? Let's take f of 3001. That would be n minus 2, so 2999, right? 2998, is it? Huh. What happens to 3002? No, it is 2999. Huh. That will be 3000, right? What will this be for 3003, 3001? What will be this for 3004? So this is obviously a linear thing. This will happen. This will keep on increasing as n increases. But this part is interesting. We have to know these values to do this. So let's take, so we have this f of n is equal to f of n plus 5 for n less than or equal to 3000. So let's see what happens at 3000. If it is 3000, this is f of 3005. And what was f of 3005? 3005, that was 3300. And what was f of 3300? 3003. This was simply f of this was simply 3001. All right. All right. Okay. I want to see a pattern. I want to see whether there is a pattern when n is less than or equal to 3000. Otherwise, that complicated question, you cannot try to generalize it otherwise. You have to try to find a pattern, right? Okay. Now that was 3000. I'll take 2999. What happens? That will be f of 3006. That will be f of 300. Doesn't that? What is it? Minus 2, right? And this will be 3002. What is f of 2998? f of 3007. f of 3005. 3003. All right. If I go further down, I'm guessing something interesting should happen. F of 2997 will be f of 3002. What is the interesting thing which is going to happen is that f of 3002, we just oh, why is it 3002? Yeah, obviously it is 3002, and we calculated that to be f of 3000. Now we know f of 3000, we have to use f of 3000, that is 3001. What happens to f of 2997 96? f of 3001, that is f of 2999, right? So you see this, it keeps repeating. And 2999 was, what was the value for 299? It was 3002. You see, it just keeps on repeating. It will again repeat. So 2995 would be f of 3000. What was f of 3000? 3001, that was f of 3001 was 299. So you see 3001, 3002, 2999. These things will repeat. 3001, 3002. We are supposed to have 2999 here. What's happening? If I add 5, okay, something wrong. If I add 5, I'll get 3002, and this will be f of 2999, and f of 2999 is, I'm sorry. This is f of 3000 here. Calculation mistake. And f of 3000, we just calculated it. What am I doing? I'm supposed to add 5. So if I add 5, I'll get 3003, and 3003 will be 3001. F of 3001 will be f of 299. Yeah, okay. So don't do these kind of mistakes. Yeah? All right. So 3001, 3002, 2999. This has to repeat, and it is repeating. You see, 3001, 3002, 299. Okay, so what is the relation between f of 2995 and 2999, 2996? So it is repeating in threes. So I would want to write it as f of n is something plus n mod 3. Can I do that? Right? That makes sense? Plus or minus. It can be minus also. So here it is. What is the difference? What is n mod 3? N mod 3. Here n mod 3 is so let's see, let's start from the beginning. So it is 0 mod 3. This is 2 mod 3. This is 1 mod 3. So this would be 0 mod 3, 2 mod 3, 1 mod 3. So when it is 1 mod 3, you are having 2999. So I'll write it like this. If n is 0 mod 3, you have 3001. N is 1 mod 3, you have, for 1 mod 3, you have 299. 2999. And if it is 2 mod 3, you have, can I combine these things together? Can I combine? I don't know. You tell me in the comments, right? So this is the generalization. Now you can, I think, find out what is f of 2022. And as you can guess, question is from 2022. So that's all for today. Rest you can figure out. So it is about observing the pattern and calculating it properly and not making mistakes. So don't do that. Don't make any mistakes. Have fun. All the best. Bye. Hello everyone. Welcome to this video. I hope you're all doing great. And I hope you're all preparing well for the ISI and CMI examination this time of the year. Doing PYQs is the best way to solve, as I keep saying this repeatedly again and again. Yeah. I hope you're following that. And yeah, and there is this IOQM preparation course which we are launching. I hope you'll join that. It will be 3 times a week, Tuesdays, Thursdays, and Saturdays during the night time, 9 p.m. to 10:30 p.m. So it will fit with any other preparation you're already doing for JEE, NEET, etc. So that's the thing about it. And let's move ahead. So we have the first question on the screen. Please pause the video and try to solve it ASAP. All right, I hope you have done this. So this is a very, I felt this is a very easy question. Yeah, actually. P of x is a polynomial. Again, why does this keep happening? I think Arey yaar, something keeps on happening to this. See, every time. I just don't understand. Sorry. Now, this is a polynomial, right? With integer coefficients having this property. Fine. Q of x is definitely not a polynomial, not required to be a polynomial. I want to find, using this relation, something about P of x, first of all. What can I do? How do I use this? So instead of x, if I replace x with 1 minus x, I'll get something like q of 1 minus x is equal to q of 1 by x, right? So here, why did I do this? I simply wanted to have something simple. This is much easier to do compared to this, right? So what do I get here? I already have q of x equals to q of x by x into 1 minus x, right? X into 1 minus x, and I have to do this. So what is q of 1 minus x? It will be p of 1 minus x by 1 minus x into x. What is q of 1 by x? That will be p of 1 by x divided by 1 by x into 1 minus 1 by x. So x minus 1 by x. I can do this. This can be written as x square p of 1 by x by x minus 1. So how do I relate these two? And these two are equal, right? So immediately I will have p of 1 minus x by x into 1 minus x is equal to x square p of 1 by x divided by x minus 1. So I can cancel out these two and I'll get a minus here. And this will imply that p of 1 minus x is equal to minus x cube into p of 1 by x. Amazing. Okay. Now, this tells us a lot of things about p of x. Now, remember, p of x is a polynomial, right? So, because it is a polynomial, if you go and see if p of x can be written as a n x power n, a n minus 1 x power n minus 1, and so on, that would mean that p of 1 by x will be a n by x power n, a n minus 1 by x power n minus 1, and so on. So if I multiply x cube, I'll get a n by x power n minus 3, right? So the power will be taken a little bit here, a n minus 1 by x power n minus 3, and so on, minus 4, and so on. Now, what do we know? We know that if I multiply x cube, I am getting a polynomial back. This is again a polynomial. Again a polynomial. What is the definition of polynomial? Polynomial has no denominators. At least in the variable is never in the denominator, right? So if we don't have it in the denominator, that means all of these don't exist. That means n is greater than or equal to what? n is greater than or equal to 3. I want n minus 3 to be less than 0, right? So that it is in the numerator. Less than or equal to. N is less than or equal to 3, not greater than. Okay. So P of x is at most a cubic. At most a cubic. At most in the sense the degree is at most 3. Degree of P is less than or equal to 3. Right? This is the information which we have. Now let us look at the question. What does the question say? What is the question asking? Find one such polynomial with the smallest possible degree. So let's see, can linear do this? For a linear polynomial, is this possible? Definitely not possible, because if P of x is linear, if P of x was linear, then this is a quadratic, right? But that is a linear. So for linear, it is not possible. Does that make sense? If this is linear, it's not possible. So let's see. Let's start with the least one. Can be, let's say, P of x is it monic? Did they say monic by any chance to make it easy? No, it's not monic. Well, okay, chalo. What can we do? So P of x is ax square plus bx plus c. So P of 1 by x is a by x square plus b by x plus c. Yeah. And P of 1 minus x is a 1 minus x whole square plus b 1 minus x c. So first of all, I also want to find minus x cube P of 1 by x. That would be minus ax minus bx square, right, minus cx cube. Interesting, right? And see, so this is 1 minus 2x plus x square plus b into 1 minus x plus c. So if you see, it is ax square, quotient of x will be minus 2a and minus b, x plus a plus b plus c. All right. So this is P of 1 minus x, and this is this. So these two have to be equal. So you see that this has to be equal to minus cx cube minus bx square minus ax. Right? So how is that possible? It is possible only when c has to be 0. Right? Because there is no x cube term in both of them. Talking about quadratic here. So c is 0. What else? A has to be minus b, which implies a plus b is 0. Right? So this is 0. There is no constant term. Very good. And 2a plus b is equal to a, which simply again means a plus b equal to 0. So that is the condition. So the only condition that the least degree thing to satisfy that is c is constant, c is 0 and a plus b is 0. This is the condition, right? So the first one is solved. Smallest possible degree. So degree is 2 and so on, and we have found it. Second one, find one such polynomial with the largest possible degree. Show that the degree of such polynomial is unbounded. No. We already found that the degree of such polynomial is bounded. It is wrong. It is bounded, right? Bounded by can be at most 3. So we will find if it is possible for degree 3. So it is all calculation, guys. I want you to do this. I don't want to calculate. I don't like calculating. That is your job. So p of 1 minus x should be equal to minus x cube p of 1 by x. So we will this time take p of x to be a cubic, ax cube bx square cx, and you do that, right? I totally 100% believe that you are capable of doing this. Find the relation between a, b, c, d, which you have. You need not solve it. You will finally get to one point where it is solvable. But it is possible. You just have to show that. All right. Okay. Next question on the screen. Please try it. Give it a try. Pause the video. Give it a try. It's a very interesting question, this one. So, yeah. Golden function, right? You'll soon realize why it is being called a golden function. All right. So, find all the golden functions, if any, of the form this. Right? So let's see if such a form is possible. So f of x is equal to a x power b. That implies f dash of x is ab x power b minus 1. And what is the inverse? So let's say y equal to ax power b. That will imply x power b is equal to y by a. That will imply x is equal to y by a whole power 1 by b. Since we are talking from r plus to r plus, it is totally possible. It is no problem. So f inverse of x, I would say, is x by a whole power 1 by b. Now, is it possible that f inverse of x is equal to f dash of x? So that means x by a whole power 1 by b is equal to ab power x power b minus 1. So how do we do that? So for one, you see that 1 by a power 1 by b, x power 1 by b should be equal to ab x power b minus 1. So for one, degree should be equal. So if we are taking degree equal, 1 by b is equal to b minus 1, we are getting b square minus b is equal to 1, or b square minus b minus 1. And it so happens that this is the equation whose roots will be the golden ratio, pi and minus 1 by 5. Yeah, golden ratio. So that's about degree. And what about a? The moment you find b, I think you can find a which satisfies, a into 5 is equal to 1 by a power 1 by 5. So I hope it shouldn't be difficult. So a power 1 plus 1 by 5 is equal to 1 by 5. Yeah, and so on and so forth. So you can solve this. So you'll find a, but the b is the golden ratio. So yes, the answer, find all golden functions, is yes, you'll get 2 golden functions. I'll write in yellow. 2 golden functions. All right. So find all golden functions, if any, of this form. Is this possible? Let's see. So if f of x is equal to a b power x, interesting. So what is f dash of x? It is a b power x natural log of b, right? We are assuming b is positive, obviously, because we are taking from r plus to r plus again. And f inverse of b x, how would that be? So if y is equal to a b power x, b power x would be y by a. and what would we do? X is equal to natural log or log base b of y by a. So that is the inverse. So f inverse of x is, okay, I don't think this is ever going to happen, right? A logarithm and an exponential is never going to be equal. The graphs are never going to be intersecting, right? So this part is an exponential function and this part is a logarithmic function. They just don't grow that fast at all, right? So it is never going to be possible. This is never, all right? So yeah, so this is not possible. So in both cases, A and B are suitable real numbers. Suitable in the sense here we have A has to be positive, B can be anything in the first one. B need not be positive. In the second one, B has to be positive, and it so happens that it is not possible. Now, what do we do? What can we do? Second one, we can solve the second one. Show that there is no one-to-one and onto function. I hope you know that this is called a bijective function, right? From the whole real, so I want you to notice the difference. It is not here, initially it was given r plus to r plus, but here we are given r to r such that f dash of x equal to, so f is never a golden function if it is a bijective from r to r. That is what is to be proved. Given f from r to r, a bijective function. So I want you to understand something very, very clearly. A bijective function is in r to r means it is either something strictly increasing or it has to be strictly decreasing, because for all values of r it has to take some value of r. So it is never possible that it is taking a curve back and going like this, right? It is not even possible to have a curve like this. No, it has to be strictly increasing, because if it is like this, then there are multiple points where, so it is basically, it's not onto, sorry, it is onto, it is not 1, 1. For it to be 1, 1, it has to be strictly increasing or strictly decreasing. So I hope that is understood. If that is understood, then the explanation becomes very, very easy. You can actually directly write it. It's not a problem. You can write that because it is a bijective function from r to r, it has to be always strictly increasing. And if it is strictly increasing, that means that f dash is either strictly increasing or decreasing, both. It's either this or f dash is always negative. But something it has to be for all x. For all x, it has to be either positive completely or totally negative. Whereas if you, so if f is bijective, implies that f inverse is also bijective. Obviously, that is kind of the definition of bijectiveness, that it is invertible, right? So if f inverse is also bijective, that means f inverse takes all the values of r. That basically means it can be, it is both positive and negative. So it cannot be fixed to only positive, only negative, right? So it is a only here. I hope you understand that. Only this or this. So f inverse equal to f dash is not possible. That is the proof. I hope you understood it. You have to just write it in the word, in words. That's it, right? शब्दों में बयां करना उनके लिए. So that's it. So take care. Tata. We'll solve more problems. Bye bye.